Good evening, students. This is the 13th session of your class, chapter number 4, linked list concept. So, I think this is the end of the chapter number 4 concept. So, last class we had discussed about the concept of the operations on the linked list concept. There are the number of different types of the operations are there. The first is that creating a linked list. Second is an inserting a linked list. So, inserting a node into the linked list concept can be categorized into three different types. One is that inserting an end at the beginning of the linked list, inserting an node at the end of the linked list, and inserting a node at the given positions. There are the three different ways we have to be inserting a node into the linked list concept. The next operation is an deleting as an item from the linked list. Here also same as like an insertion. Here also three classifications of the type of deletion operations. There are the three classified into the three different types. One is that the deletion of an item from the first node, deletion of an item at the last node, deletion of the node at the given position. So there are the three different types of the operations. The first is the deletion of the first node. Here we can easily delete the first node of the linked list by changing its starting to the point to the second node of the linked list concept. If there is only a one node in the linked list, the start can be stored with the null after the deletion has been occurred. So this is the diagrammatic representation of the deletion of the first node concept. Here the start, it is the address of the first node, and here this linked list contains the four nodes 50, 40, 70 and 20. The 50 is the first node, the 20 is the last node. The last node indicated as that the link field, it contains the null, so that here is a x. X is indicated as that it is the null. So here the start, it contains the address of the first node. The first node is a 50. So here by changing the starting to the point to the second node, so after that the 50 node has been freed, that is deleted. So that this is the concept of the deletion of the first node. So this is the diagram, sorry, this is the algorithm of the deletion of the beginning node. So this is the algorithm. First copy the data into the first node to the any variable, then delete the first node of the linked list concept. This is here also some of the steps are there. The step 1, starting the algorithm. Then second step, p, which is equal to a start. The start, it contains the address of the first node, that is named as an p. Print the data of p, that means the p is a first node, then first node data will be an, so here is a 50. Then the start, which is equal to link of p. The link of p, that is the link of p is a second node. The second node will be attached to the start. So start, it contains now, so it is the address of the second node. Then free, that means free means delete the p node, that means deleting the first node. So this is the algorithm for the deleting the beginning of the node in the linked list. Second operation of the deletion is that the deleting a node at the end of the linked list. To delete the last node, we should find the location of the second last node. By assigning null to the link field of the second last node, the last node of the linked list can be deleted. So here diagrammatic representation is start, it contains the address of the first node. In the linked list, it contains the four nodes 50, 40, 70 and also 20. So first we have to find out which one is a second but last node. So we have to tracing out the first node is a 50, then the second node is a 40, the last but second node is a 70. So this is named as a P1. So here the last node is a 20. So 20 node, this will be copied to the any variable. Here the P1 link field, it contains null. So then freed, that is deleting the 20 node. So this is by assigning null to the link field of the last but the second node, the last node 20 will be deleted. So this is the diagrammatic representation of deleting a node at the end of the linked list concept. So here is algorithm. So here we have to use the two pointer P1 and also P2. P1 is a pointer that is used to traversing a linked list of the last but second node. Then pointer P2, it keeps the location of the previous node of P1. So this is the steps. It is starting the algorithm. The P2, it is named as the address of the starting P2 node. Then while the link of P2 is not equal to null, the P2 will be P1. Then the link of P2, that is named as a P2. This is the tracing out the concept of the last but which one is the last but one second node. So print the data of P2, then copy that one, then link of P1 will be null, that is named as a null. So here is the link of P1, that is the null, the free P1. So this is the algorithm for the deleting a node at the end of the linked list concept. The third type is deleting a node at the given position. To delete a node at the given position, some of the procedures are to be used. First, we have to find out the node to be deleted and the previous node has to be detected. Then delete the node to be deleted by changing the location of the previous node of the node to be deleted. So this is the algorithm. Here the two pointers are there, P1 and also P2. The pointer P2 is used to traversing a linked list from the beginning to at the given position. Then the pointer P2 has a location of the node which node has to be deleted. Then P1 keeps the location of the previous node of the P2. Starting the algorithm is step 1. Then step 2 is a traversing, that is count, which is initializes to 0. The P1, it is the starting node, while the P1 is not equal to null, so which is count is incremented by 1. Then that means 1 by 1 up to where the position has to be deleted. So that is a tracing. If the position is 1, call the delete beginning function. So that if the position is 1, so we have to calling the function delete the beginning concept, that is a deleting the node at the first node. Then if the position which is equal to count, that is the end, so call the function delete the end of the linked list concept. Or else if the position less than count, that a given position, the starting node, that is named as a P2, then I is equal to 1 up to the position, then we have to find out that which node has to be deleted and the previous node will be the P2. Then the link of P2 to and the P2. Then the data, print the data of the P2 that will be deleted. Then the link of P1 which is equal to link of P2, then the free P2, that means deleting that P2. Or else the invalid positions will be occurred, then return. So this is the algorithm for deleting a node at the given position. The next concept is that advantages of the linked list. Here the some of the advantages of the linked list are the dynamic data structure, insertion and deletion, no memory wastage, implementation. The dynamic data structure, which means that already you know that what is a data structure. The data structure is a way of organizing the data in the computer system concept. Dynamic means that means always changes. So that is dynamic means when we have to adding the any node into the linked list, when we require that we have to adding the node into the linked list. When we want to unwanted node has to be occurred in the linked list, we have to delete that concept. So that the dynamic elements, that is always changes in the data structure. The second is the insertion and deletion. So when we need, we have to inserting a node into the linked list. When not needed, that means deleting any node from the linked list. So that insertion and deletion. Third is no memory wastage. So here when we want and the unwanted concept is that here the no memory is wastages. Implementation. So here the linked list concept we have to implementing the number of concept here is there. So that is a sorting technique, searching techniques like this. So that these are all the advantages of the linked list concept. Disadvantages: memory usage, then traversal is risk, then the reverse traversing is also not possible. So these are all three disadvantages of the linked list concept. So this is the end of the session. Thank you.